Here's the Wikipedia entry for logic. When you think about ones and zeros in your code or in your hardware or in software, or when you're watching a movie or when you're watching a TV show and you're considering or you're looking at stuff that's on screen and it's ones and zeros, and that's the typical way that that stuff is represented inside of the software space. What it implies underneath that some people don't fully understand, and understandably so, is that ones and zeros are just on-off switches on repeat across time. That's all it is. In some cases, that means on-off in terms of electrical signals in your hardware. And in some cases, that means that your electrical signals just have a bigger strength if it's one, and a lower strength or a smaller strength if it's zero. That's all ones and zeros are. When you're typing in code, you're using the laws of logic to convert some kind of subset of language into those ones and zeros. All those ones and zeros get executed on hardware via electrical signals. And so the ones and zeros represent the translation of the code that you write to the electrical signals as on-off switches. I'm generalizing a bit here for the purpose of the tutorial. This is really simple. You have three rules of the laws of logic. The logic itself is used as a formulation of reasoning in order to determine whether something is true or it's false. There are other ways that you can use logic, as so you can use like a negation of something to determine its false value or truth value or things like this. However, just generally speaking, again, it is a formulation system or a system of formality that you can apply reasoning capabilities to come to a conclusion. There are three rules. The first rule, well, it's not even really the first rule, but we have the law of excluded middle. So let's just go look this up. Laws of logic, law of excluded middle. So the law of excluded middle states that either the proposition or its negation is true. That means that something either is true or its negation is true. So you can think of it this way. So now we're going to look at some code, all right? It's really, really simple. So we're going to take over this game and we're going to zoom in real nice and tight. Actually, you know what I should do? I should just do this. Where did it go? I'm going to have to edit this out. Here we go. So if you look at some code, you can actually open this up. And you can open it up on any browser, and you can write this code. This is JavaScript, but you can do this in C too. So all the code that I'm about to write will run in JavaScript, but this is such a basic code, you can run it in any programming language because it's a fundamental law of software programming. So either something is true or its negation is true. So something like this, it would be, you can think of like a variable as something, and you can go 1, 2, 3, all right? And so we have a variable. This thing stores a value of 1, 2, 3 on your machine. Doesn't matter how, that's all magic to you, right? So we have this variable, and then we're gonna go something equals 1, 2, 3, okay? And we're gonna spit out, you don't need to know what this is, I'm just gonna spit out true here. Does something equal 1, 2, 3? And so here you go, you have it. Now what you can do is you can go, if something is not equal to 1, 2, 4, is this true? It's also true. So the negation statement, which is something itself or is it not itself, is the law of excluded middle. Congratulations, you've picked up 1/3 of all programming logic you're ever going to need to know. The next one is laws of logic. It's excluded middle, and there's another one called non-contradiction. The law of non-contradiction. For any given proposition, the proposition and its negation cannot both be simultaneously true. So how would we do this in terms of code? This is really simple again. So you would go something like, if something equals 1, 2, 3, and something equals 1, 2, 4. That means that something cannot both be true and not itself. It cannot be itself and not itself, right? true and not true. Its negation cannot be true at the same time. It itself has to be what it is. You can't do a negation value and go console log true. It will never run, right? So it never runs because you can't have the negation of something be true at the same time, which leads to the last law of logic. Laws of logic, identity, law of identity. So here what you have is the law of identity states that each thing is identical with itself. As in, if we just take back this and we go, does something equal something? This should be true. It is. It's true. Congratulations. You've now reached the introductory level of all programming concepts you can possibly dream of. Here's why. When you think about how this translates into hardware-based mechanisms, this code gets translated into a bunch of ones and zeros, ones and zeros, ones and zeros, ones and zeros, ones and zeros. And then what happens is that these ones and zeros tell your hardware, turn an electrical signal off or turn it on. And there's a whole branch of these. They happen, one thing triggers another thing, triggers another thing. There's a way that you can look at this if you go through ARM CPU architecture diagram, I want to say. There's a flow, right? It's kind of like this. I think this one's a good one. You don't need to understand anything here, okay? Just your eyes can just gloss over the words. You don't care about any of this as part of this introduction, but just understand these arrows. There's a whole series of steps that have to be taken. And when you're writing code, you're triggering certain steps and certain flows. And all of these things operate on the laws of logic. Let me close all this and go back to this here. All of it depends on this. That's the laws of logic. That's it. Whoever just gave me a follow just now, I appreciate it. That's it. Because any electrical signal that has a 1 cannot be a 0. Any electrical signal that has a 0 cannot have a 1, right? They must be itself. So the law of non-contradiction, the law of identity, and the law of excluded middle all operate on this hardware. Imagine if you had ones and zeros that could be 0.5 or like 1.8 or things like this. The entire process of a logical chain of series by series, you're doing this like, step by step, that would all be broken because hardware at the end of the day, no matter what code you write, whether it's TypeScript, JavaScript, C, C#, C++, doesn't matter. It's all going to get translated into a series of steps that must adhere to the laws of logic. At the end of the day, even AI must adhere to this. Everything must obey physics, even the hardware underneath. Congratulations. That's your introductory tutorial into programming. If you understand the laws of logic as it happens to be applied to programming, now you can jump into some code like C and you can start playing around with C and compiling it. Just grab Clang, C-L-A-N-G. You grab this thing or something like this. There's a few. You don't need to use Clang. You could just pick any. Pick any compiler and go for it. And then what you do is you don't even need structs or anything like that. Here, I'll show you we'll just go right to the freaking bottom. Here's what you do. You have to have a main function. Okay, you can go look this up. It's really simple. A main function tells you that there's an entry point into your operation. And then you just have a main function. You just start doing things like 1, 2, 3. And you can start writing the exact same code I just did on string. It's 2 equals here. Or something like this, right? At this point, note now what we've discovered. At this point, the entire concept of the laws of logic and the way that I wrote the code is now only down to quirks of the language. That's why these principles are so translatable, because now all you have to do is take the stuff I wrote over here and just figure out the quirks of the language itself. not the fundamental understanding of how this thing is going to operate in your hardware and how this logic is going to execute. Now all you have to do is just jump between languages and learn the quirks of the language. What's a U32 mean? It's just a number. It's an upper limit on a number. That's it. Do you have to use triple equals or double equals? Well, in some languages you can use triple equals and in some you can use double, but in both cases you're getting the same kind of evaluation, generally speaking. Now at this point, you're so well versed simply because of the last 10 minutes that we've spent going over this. You're so well versed, you can jump into any other language and know exactly what's going on, and all you have to worry about now is the quirks of said language, not the fundamental underpinnings of how the hell this thing operates. That's a big difference. So pick up C now and you can start playing around with this. Start compiling some code and you're off to the races. Congratulations, you now know programming. That's it. There you go. We just did it. We went over it. It's as simple as that. If you know this stuff, you know way more than most programmers understand as an operational mechanism of how these things work. And that's going to give you insight into data structures. You're now going to understand why certain data structures are worse than others. It's going to give you insight into why multiple layers of abstractions and obfuscations are not necessary or in fact are detrimental to the performance, security, output of things that you have. It's like this fundamental underpinning of programming is so mind-blowingly simple and at the same time so mind-blowingly necessary for people to understand why the tech industry is in such ruin as it is today. We have neutered the ability for people to understand even basic things like this. There you go. I did it in 10 minutes. It's as simple as that. No tutorial on the planet, no university degree, no college course, no speech, no conference, no YouTube tutorial. None of them will teach you what I have taught you right now. None. At least none that I have found, and I've gone through quite a few. All right, here we go. Okay. Tutorial number 2. All right. What are variables? This is a variable. Number 1, you use variables all the time, every day in your life. You ever used a cooking recipe? You're using variables. You ever done simple math? You're using variables. You ever tried to figure out what a coupon discount would mean in terms of dollar amount when you see the full price and then you have like a 30% discount? That's a variable. Those are variables. What variables are is a place in your hardware to store a thing. Typically a number associated with a series of ones and zeros, which indicate on-off switches, which are representative of that number at that location in your hardware. So you can imagine a variable, something like what I'm doing right now, number 1, here in C code, 32. Let's go 69,420 just for the hell of it, because it's funny. Ha ha ha. Aren't we immature idiots? Yada, yada, yada. When I go and compile this, what happens is that this number gets stored in a place you could physically point to in your hardware. If you were small enough, if you could be Ant-Man and go in there. That's what a variable is. That has a place. It has an address, much like an address to your home where you are stored. This thing has an address where you have to go and reach in and grab this value. When you use a function, what you're doing is passing in two variables that store two different places in your hardware that have an address that points to that thing, which are two different values. Your function then executes a series of imperative ones and zeros. So if we go back to let's see if I even have it up. I don't have it. You could go, what the hell was it? CPU, like ARM architecture diagram. I don't know, whatever. It's that series of chains, like all this gobbledygook that doesn't mean anything to you right now. There's a series of steps that happens to determine, okay, what's the value that lives at this physical location? What's the value that lives at this second physical location? Then I'm going to execute a series of things, and then I'm going to add them up, and then a series of ones and zeros are going to come out of that, and it's going to return the total value of both. That's what variables are, and that's what functions are. And you use this stuff all the time. For example, when you use a mixer while you're cooking, your mixer is going to accept some ingredients. Your ingredients will be these two variables. Your mixer is going to be the function of mixing these two variables such that you get like dough or some kind of other mixture out of it. And your blender just automatically does it. And you can constantly put in two or more different variables and get a different output. And so the function of the blender is that it receives inputs and gives you an output. That's exactly the same thing here. But again, at the reductive level, all this does is operate on the laws of logic. That's it. This reduces to on-off signals operating on non-contradiction, law of identity, and law of excluded middle to give you to take the inputs and give you the output. You have now learned a very fundamental basic set of C. That's it. What are arrays? Here's what arrays are. You use this all the time as well. Do you have kids? Do you have more than one kids? Here's an array. Let's say you have 3 kids. You have 3 kids and they all have a value. Let's say it's a name. You can represent this value as a name. You now have 3 kids, which you can represent as an array of 3 kids. Boom. That's what arrays are. Do you want to know what structs are? Do you want to know what structs are? Let's say car. I think it's car name. Structs are nothing but a different view into arrays. That's it. So if you think about kids being 3, you can think of it as a multidimensional array. So let's imagine that you have kids 3, right? So you go kids like this. And then so you have like 3, right? So let's do it. And it's like first kid, that's the name. Sorry. The name of my first kid is first kid. And then I have a love value for the first kid of 10. And then you have a second kid. And then you have a third kid. And I love my second kid a little bit more than my first kid. Then you have your third kid, and you love your third kid just a little bit more. Structs are just an individual version of this array in a different view. That's it. It's like the hex to binary. Congratulations, you basically picked up everything that you need to know in C. Boom, you're done. We did it in 20 minutes. We did it in 20 minutes. And you picked up the laws of logic, you picked up basic programming paradigms, and you picked up basic principles of C. You just did it. This is going to get you so far. It's unbelievable. And this is the stuff that React bros, Rust bros, memory safety bros, obfuscation bros, AI vibe code bros, ship it fast bros, whatever, Vue, all of this stuff. This is what these bros don't understand. All of these people do not understand this. It is so simple and straightforward. And if you stick to first principles and you maximize their use case, you have now just learned C, you've now learned the principles of programming, and now all you have to do is jump into something like JavaScript. Let me go back here, and all you have to do now is learn quirks. Quirks like, what's the difference between a double equals for comparison versus a triple equals for comparison? That's it. You're done. Now you just learn quirks. Your fundamentals don't change. You can apply this across the board. When you're looking at something like React that overcomplicates the hell out of the web, you can look at something like what React does and you can go, well, hang on. React creates a virtual DOM. Now this is going to be external to the tutorial. Maybe I'll include it. But React creates a virtual DOM, or at least it used to. I still think it does. So you can look at what we have here. This is DOM, Document Object Model. And these are all like a structure of little elements in your website. Every little button, every little thing becomes one of these elements. And so what React does is, well, this is slow. So what I'm going to do is I'm going to re-represent this entire structure inside of a memory space. Well, guess what? Now you've learned the fundamentals of programming. Do you know what that means? That means when React creates a virtual version of exactly what you're seeing here, it's taking everything that I'm doing here on this video game and recreating a virtual version of that entire thing. Where do you think that lives? That lives in memory, which means now you have 2 versions of the same thing. So when you try and do a change in one, you then have to map that change to another. Do you know what that means? That means that the law of identity must take place, which means that a thing must be itself. So now you have to run extra operations to get these 2 spaces to match. Do you see how these very simple fundamental paradigms allow you to discern how React is an absolutely bullshit language or paradigm framework, whatever, that has been absolutely cancerous to the entire tech industry and has brain rotted everybody into thinking that obfuscations and abstractions are the bee's knees when it's not. It's literally not.